Hi, my name is Barry Olney from In-Circuit Design. This is a quick demonstration of the new iCD Materials Planner. The Dielectric Materials Library in the iCD Stackup Planner has over 33,000 rigid and flexible materials up to 100 GHz, produced by over 60 different manufacturers, containing over 700 series of materials. So often it's a daunting task to ascertain which is the best material for an application. The iCD Materials Planner allows you to compare dielectric materials based on manufacturer, fabricator, frequency, dissipation factor, which is loss, and dielectric constant. This enables the designer to make an informed decision on which material is best for their application. Generally, the selection metric for dielectric materials is the amount of loss that a transmission line can tolerate and is proportional to the frequency and rise time of the signals. The iCD Materials Planner is subdivided into 5 default tabs, which give the novice PCB designer a heads up as to what to select for his application. So these 5 different tabs here, we have ultra low loss on the left here, and these are samples of the most popular materials. Now the ultra low loss has a dissipation factor or loss of less than 0.005, and you can see here we have a horizontal line which represents the DF, and we have a vertical line which represents the frequency in gigahertz, which is 20 gigahertz in this case. So what we need to do is look for a material that is in the lower right quadrant of the graph. So any material that is in this area here would be fine for our application in this case. The low loss materials, they have a loss of less than 0.01. The mid loss has loss of 0.015. The standard loss, 0.02, and basic FR4 is anything above 0.03. This is similar to a typical competitive analysis that a materials manufacturer may show to say, demonstrate the difference between Isla versus Ventec and Rogers, for instance. But it's far more comprehensive with over 60 vendors to choose from. So we have these default tabs that are there for your convenience, just to show you, give you a rough idea of what to select for your application. Alternatively, you can create a profile for each PCB vendor that you commonly deal with. And this will display the complete range of materials that fab shop stocks, ranging from basic FR4 to low loss materials. And these materials can be checked on and off. You can check all on, check all off, etc., or you can individually check them on and off. So let's open a few profiles that I've created for there's a couple of US manufacturers, Advanced Circuits, and Shenzhen Circuits, which is a Chinese manufacturer, and another one, Streamline Circuits from the US. So we'll take a closer look at Streamline Circuits profile. And you can see here we have a lot of very low loss materials, which are Rogers, basically Arlon, and we move up the line, there's a few others like Nelco, which is fairly low loss as well, and you'll find there's some Isla and TUC, Taiwan Union Company, more Isla, etc., up to the basic sort of FR4 type materials. So if you're looking for a basic sort of material, you may say, okay, I want 0.01 loss, and so you select a material that's close to here. So here an Isla FR408HR would be the ideal choice. We can also compare dielectric constants, and you'll see here that the dielectric constant of most of these materials is much the same, but there's one that really sticks out up here, which is a 3M embedded capacitance material. That's this material over here. Now, a dielectric constant of 22 seems quite high, but remember this embedded capacitor material is a core, and it's in between two planes, and we want as much capacitance as possible, and a high dielectric constant gives us a high capacitance. So now what I'll do is I'll create a new profile. So say for instance we want to use a ISO or iSpeed IS in the US. For mass production of boards we would go to China, which is a more cost-effective approach. So let's take this ISO material and we'll copy it, and we'll add it to a new profile. And by the way, I'll just call this my profile. So you can basically build up your own board library from this. You can also add materials to it. So we have an iSpeed IS, So we want to look for an equivalent material that's stocked by an Asian fabricator. So let's first of all look at EMC, and we'll just set the DF to 0.65, which is close to our isolin material, and we'll set the frequency to say 5 gigahertz. So we're looking for a material that's somewhere around here. So if I look up here, you'll see that the EM888 is very close. So if we just copy that, and I'll delete these other ones here, and I'll paste this back in. I could also select the EMC material by individual dielectric material. So here I could go to EMC, and then I get a list of materials, and I select the 888, and it gives me that material. So here we have the isolin material, and we have the EMC material. So that's one competitor we could look at. Let's look at Taiwan Union Company. And we'll have a look at the materials down here. That's probably a bit low, the Thunderclad 2. There's our isolin material. There's our EMC. And here we have a TU872 SLK special. So this is that material there. So I'll just copy that. And again, I'll just delete the ones we don't want. And paste the other one back in. So here we have our TUC material up here. And let's look at another manufacturer, and we'll say that, okay, we want to look at Shengi, which is actually Panasonic. And we want to look at a material which is near our horizontal DF of 0.0065. And we see here that a somatic 4 material is a good one. So I'll just delete all the others here. And we're going to, of course, sort this in alphabetical order. So here we have our isolin material, we have our Shengi, we have the EMC, and we have the TUC material. And you can see that, at 5 gigahertz, which is our target frequency, that the Shengi Somatic 4 is probably the best equivalent to our iSpeed IS material. You can quite easily add materials, like I said, just by copying and pasting materials. You can just select a few and copy and then paste into another profile. So it's quite easy to build up a library of components, and as I mentioned, you can add a material so you can create your own library. Thank you very much.